Alright, hello everyone. Today I'm going to be doing a demonstration of us starting a new CloudLab experiment, importing our attack scenario to this experiment, and then actually running that attack scenario. So first things first, we have to create a new CloudLab experiment on CloudLab. For this part, we're just going to click Next. Now, these settings we don't really need to mess with. However, there is one setting right here, number of public IP addresses. If you're going to be doing a bigger experiment with more than one pair of attack victim computers, you're going to need more of these public IP addresses. By default, the highest number you can assign is 16, and because 2 of those IP addresses are needed for networks, you can have 14 computers or virtual computers running the attack image that you can assign a floating IP address to. And I'll explain that more once we get to that part. But for this experiment, we're only doing one attack instance and one victim instance, so we're just going to go with 4 public IPs. Wait for this to load. Alright, so we need to give our experiment a name. I'm just going to do a demonstration. And there's multiple clusters you can choose from, and basically this is just computers at University of Utah, University of Clemson, University of Wisconsin that run these experiments. So you can do, if you hover over the little circle here, it'll show how many PCs are available on these clusters. I'm just going to go with the first one, and we're going to click Finish. So the experiments take about 10 to 15 minutes to create. So I'm going to skip around a little bit. A lot of these processes do take a little bit of time. So now our experiment is ready, and you can tell by when this says this is ready and then when this says this is ready right here, we can go ahead and open the OpenStack dashboard. So every experiment gets a randomly generated password, which I'm going to copy to my clipboard here, and then we can log in to our experiment. So the domain name is always going to be default, the username is always going to be admin, and then, like I said, for every experiment you get a randomly generated password. So when we first open this up, there's no instances. However, OpenStack goes ahead and creates some default networks and routers, which I'll show you now. And like I said before, we're only going to be doing one victim instance and one attack instance, so we're just going to attach them to one of these default networks. We had done a test previously to see if we could still run the exploit with the attack instance being on one network and the victim instance being on another network, but unfortunately, in order for this exploit to work, the instances have to be on the same network. But before we can import our experiment, we need to first import the images that we're going to be using. So these are 2 defaults that are here right now. We're not going to use these, but we are going to upload some new images. So what I have open here is the documentation that we started writing for running a bigger version of this experiment with more than one attack victim pair. And there's some links here that we can just copy and paste. I uploaded these to an archive to make this easier to upload these. That way the person who's running this experiment doesn't have to go and download these images to their computer. So first thing I'm going to do is copy this link here. This is the image to download the Metasploitable image. And what Metasploitable is, it's a purposefully vulnerable instance. So this virtual machine has some security flaws on purpose. It's so that we can run penetration tests on it. So the name of the Metasploitable image always has to be victim. I'll explain that once I get to the XML importation portion of this. And we need to make sure that the format is automatically detected as a VMDK file. And then we go ahead and create this image. Now these images take a while to upload because they're pretty big. The victim image is about 1.8 gigabytes, whereas the image running Metasploit is 2.8 gigabytes. So I'm going to pause and let these upload, and then we'll get back to it. So now that these images have finished uploading, we're going to move on to the process of uploading the network. But before we do that, there's a couple pieces of information that we need to get. So back here on the page where we first started our experiment, the first thing we're going to need is this randomized password. And there's some information that you have to paste into the tester script. You could just type it, but it takes a while, so it's easier if we just copy and paste this script here. So this information here always stays the same, but the first and last items are things we need to change for every experiment that we do. Now, this is the IP address for the control node. As you'll see down here, there are 2 nodes running this experiment, and we need to access the shell of the main CTL control node so that we can run an ifconfig. And ifconfig just gives us some basic network information. And what we need is this first internet address. This is the address we can use to access this control node that's running the experiment. So I'm going to paste this in here. Now we have all the information we need. So now we're going to open MOBA Xterm. This is a free open source SSH client. We were using SecureFX and SecureCRT, but those software cost money to get a license for it. So now we have a free and open source one. So this is an Amazon EC2 instance. I've already provided the private key to get into this instance and the username, so it automatically loads when I open it up. And as you can see here, we have 2 programs, our tester script and our master script. These are Python programs. And then we have the profile we're going to upload today, which is a small profile. And what this is an XML document containing all the network information of a previously uploaded experiment. So CloudLab experiments are set to expire after 16 hours. You can extend this amount of time, but you can't keep the experiment running forever, and eventually you will lose all of your network configuration that you had. So what the programs do, a portion of the programs allows us to download this XML file and then re-upload it. So what we're going to do is re-upload this XML file. So we have this here. We're going to type sudo python3 tester script.py, and this is going to load the tester script Python file. So now I'm just going to paste that information that I copied earlier, and then it's going to list the images that are on the control node on this experiment so that we know that the connection was successful. If these images weren't listed, an error would be shown instead, and we would know that we would have to fix some of this information here. So we're given a list of options. The only one we're going to be using today is loading OpenStack Cloud from XML. So I'm going to enter in option 18, and now I'm going to type the name of the XML file we wish to import. So like I said earlier, there's no other routers that we've added. So all we're doing right now is importing 2 virtual machine instances. So I'm going to go here to the network topology. And as we can see, we already have 1 instance that's been built. It's building right now. That's the victim instance. And then in a few minutes, the attack instance will load as well. So now our script is finished running, and we've created 2 instances, the attack instance and the victim instance. And before we can run the exploit, there's a few things we have to do first. The first thing we have to do is associate a floating IP to this attack image. And what this is, it's a public IP address that we can use to SSH into this virtual machine using our SSH software such as MOBA Xterm. Usually when you're running this kind of scenario, you would be doing it in a virtualization software such as VirtualBox or VMware. But what CloudLab allows us to do is run this sort of experiment in a virtual network on virtual computers. So we have this floating IP, and now the second thing we need to do is we need to launch the console for our victim machine. Now, we still haven't figured out a way around this, but there is a problem where the victim machine doesn't boot quite right away, and we have to get it running before we can actually connect to this and run the exploit with our attack machine. So I'm just going to hit Control D here, and now this is going to start loading. And after this finishes loading, it's going to give us the login screen, and that's when we know we'll be able to launch the exploit on this machine. So now we're going to use our SSH client MOBA Xterm to SSH into this attack machine. So I've copied that IP address. We're going to start a new session, a new SSH session. I'm going to paste the IP in here. I'm going to specify the username, which is just Ubuntu, and we're going to click OK. Now, I had already previously entered in the password to get into this image, but the password for this image is always the same. This is the password to an experiment that we actually created this image on. This image is one of the default images that OpenStack provides, and all we did was install Metasploit on it and some of the few things that Metasploit needs to actually run. So now that we're actually in our attack machine, there's a couple commands we need to run first before we can actually run Metasploit. The first one is we have to make the directory that Metasploit stores its logs in. This isn't created automatically, so .msf4/logs. And now we need to start the database server that Metasploit uses, so it's service PostgreSQL start. So now that's started, and now we can run Metasploit. So it takes a minute or two for it to start up, but we'll see a splash screen once it gets started. Alright, and now we are running Metasploit. So in order to run an exploit, you have to specify which exploit you want to run. The one we're going to be using is an exploit it's a backdoor that uses the Unreal RCD IRC daemon. Just a little background information on the exploit we're going to be using. This is an exploit on the Unreal IRC daemon. It's a program that's been around for a while. And a while ago, there was a backdoor that was added to the download archive of this program. And the Metasploitable image that we're using has this vulnerability. So we're going to exploit this vulnerability. So we have to do use exploit /Unix/IRC/Unreal IRCD 3281 backdoor. And now what we have to do is we have to set the IP address of the host we're going to be exploiting. This is the IP right here. We don't have to associate a public floating IP with this victim machine because it's already in the same network as the attack victim, the same virtual network. So we're going to go back here, set our host, and I'm just going to paste that IP address. And now we're going to run the exploit. It's sending the backdoor commands. And now we have access to the shell of that virtual machine. So in order to prove that we actually backdoored into this virtual machine, I ran a couple commands. The first one gives us some identifying information about this system. And as you can see here, it says that we're running Metasploitable. And then I ran ifconfig, and as you can see here, the internet address is the same one as we put in for the R host when we actually launched the exploit. So now we could run any other command we wanted to on this victim machine. So just to recap, we created a new CloudLab experiment. We imported a previously created experiment using one attack image and one victim image, and then we actually ran the exploit. Now, what we want to do is implement this on the bigger scale where there would be more than one attack victim pair, and there would be more than one exploit to be tested so that students and instructors could test this attack scenario in a virtual laboratory environment instead of doing this on just virtual machines running locally on their computers. I hope you'd enjoy it, and if you have any questions, please feel free to ask.